Hi, everybody. So first I want to say maybe we'll be talking a little bit about computer programming concepts, and I've been told that most of the people here are professionals. If not, if you need me to slow down or categorize, qualify something, please just let me know, raise your hand. I'm happy to break down the subject-object divide of this presentation as much as we'd like to. Hello? I want to give a thank you to Hans-Holger Reus and David Pirro from the Algorithms That Matter research project for inviting me here and also investing in me and giving me the time to work on a new project. It's something not to be taken for granted. I was teaching for many years at Leuphana University in Lüneburg, which is, maybe some of you know it because of the German media arts network being so close. And I had no time to do any research there. I was just teaching nonstop, which was great for its own reasons. But for me, this residency has really been a chance to kind of open up and explore new territory. So thank you very much. Yeah, so to start, lecture performance is maybe a big word, and I don't want anybody to be scared off. I'm not going to be performing to any huge extent, nor lecturing to any huge extent. What I'm going to try to share with you is research that is still in the very, very early stages. Mainly because I came to Allmatt, came to IAM to really challenge my practice and push it in a new direction. And so I'm asking a lot of fundamental questions of what it means to be a composer of electronic music, and especially because Algorithms That Matter is about interrogating algorithms, interrogating the tools that I use for composition. So really looking at how do I think compositionally and what do I need in terms of tools to either facilitate or challenge that thinking. So a bit about me. For one, I tend to, at least for the last 5 years or so, use live coding as my primary method of creating art. Both live coding as a method for constructing works. So what I mean by that is if I create an installation or a fixed media work, I would still be developing it through a sort of interactive live coded process. But also live coding as a performance practice. So really taking an empty programming text editor from scratch and slowly developing a performance from that. So if you're interested, this is my website, jonathanreus.com. So a lot of my work is on here. I won't go too deeply into what I've made in the past because I want to spend most of my time looking at what I'm making now. But I will just kind of give you a little bit of a background on myself so you kind of know where I'm coming from. So, like Yannick introduced me as, I do a lot of curation besides making artwork. So, for example, I've curated Algoraves, for example. Algoraves are kind of a live-coded electronic dance music event. This is the Algorave from Transmediale last year. But my background, and you can probably tell from my accent, is in the United States. And I'm from the South in the United States, kind of, well, Florida, which they say in Florida, the farther north you go in Florida, the farther south you get. What that means is that the southern part of Florida is very metropolitan, and the northern part of Florida is very rural. It's a bit like Alabama or Georgia, and it shares this sort of folk culture that the southern United States has. Now, my musical background, even though I did study electronic music composition in Florida, is mostly entrenched with folk music and traditional folk music, really not like when you think of folk music, you maybe think of like Simon and Garfunkel. This is not the kind of folk music I'm talking about. I'm talking about the kind of music that was played by settlers in the mountain regions, by ex-slaves who were either doing work songs to help pass the time or unify their labor, or had escaped also into the mountain regions and were well, teaching white people how to play the banjo. So I play the banjo, or I did play the banjo at one time. This kind of stuff. So this is where I come from. I come from a mixture of this and computer science. So you can imagine how well that mixes. It's like oil and water. And one of the issues that I kind of started working on when I was in Florida was, well, how to combine these two worlds. And musically, I was deeply entrenched in this traditional music world and increasingly tried to incorporate computer music into that world. So live processing of traditional folk instruments, performing live electronics with folk instrumentalists. And many times I would get kind of ridiculed, or once I even got kicked off the stage. And this really launched my artistic interests for the last 10 years, which has been into the kind of material and social context of computing in music. And particularly because why does the material and social context of one instrument, let's say computer instruments, not mix with other, let's say, material and social musical constructions of this kind of world? And this brought me to build this kind of stuff. So mixtures of folk craft. This is a part of a project I did in Taiwan with the Aboriginal tribe that was working with weaving and wood work to try to create sort of hybrid electronic folk instruments out of that. But more so, I've also tried to use the computer itself as a kind of folk instrument, as a kind of instrument that has a certain materiality to it that can bend and stretch and be torn apart. So series of performances I've done with old iMac computers where we actually perform, this is myself and two percussionists performing as a trio, where we tear apart the computers and play the live circuitry of the computers using special probes that amplify the sound signatures of these circuits and essentially make computer instruments, but with a tongue firmly in your cheek. This is a bit... And I've also done performances in more fine artsy spaces with these sorts of instruments. This is from a performance I did that was 3 hours long, where we had 3 of these computers and we literally stripped them from complete operation to bits and parts over the course of 3 hours. And in the process, musicalized any aspect of the computers that could be musicalized. So this I can only blame on my folk background, because part of the folk music tradition is that music is incredibly embedded and material. And what do I mean by embedded? You make music with what you have around you, and you make music to express certain ideas of life. Let's say you're bored and you need to pass the time because you're working, or it's at the end of the day and you're having a party and you have your friends together and you need something to do together. Now, I tend to program a lot, computer programming. So computer programming forms a big chunk of my daily life. And so a natural place for me to turn for musical expression are programming languages. I worked as a software engineer for 3 years as I was paying off my requisite American student loan debt to come here. Not here particularly, but I'm glad I'm here. But to the Netherlands. And in doing so, software engineering, computer programming became my everyday life. It kind of became the material of my surroundings. And so my response to that is to think about, in this kind of folky way, how do we do something musical with this, and how do we take this embeddedness of what I do and turn it into music? Now at Almat, I've been kind of focused on a couple of questions. Mainly, I've been looking at the notion of voice as a kind of material media. Now, voice becomes really interesting and important when we start talking about memory. And the idea of memory becomes really important when you start talking about folk music, because a lot of this folk music that we talk about is kind of embedded in archives. So many of these traditions have disappeared from the United States. And if they haven't, it's only because of a couple of sort of hero archivists, like this is Francis Desmore, who went around the United States pretty much at the dawn of recording technology being at the point where it could be taken around the United States, to record all of these traditions before they were more or less erased by process of industrialization. So it's kind of interesting, this kind of technological snake eating itself thing of the technology being used to preserve cultures, while at the same time other technologies that are linked through social and economic forces are erasing these cultures. So, but what does that leave us with these folk traditions? Well, around the 1930s, 40s, and 50s, all of these folk traditions become canonized in a series of archives. Probably the most famous and most canonical is the archive of Alan Lomax. Maybe some of you have heard of this name before. It's very famous. I wouldn't call him an ethnomusicologist, but probably some people would, from the United States, who made huge collections of folk traditionals. And so memory becomes a really funky thing here, because what was once an oral tradition, where memory was inscribed in language and storytelling, now you have memory inscribed collectively in these archives and these recordings. And when we talk about then algorithms and computational systems on top of that, that presents a really interesting perspective on memory. And I won't get too deep into theories of memory, of digital memory, but one of the lines that I really like to draw, I'm trying to draw in this research residency, is a link between a sort of archival way of having memory and the way that machine learning algorithms remember, especially supervised learning algorithms, which are trained on a data set and then predict recombinations of that data set in some way or another. So in a sense, they're taking a history or taking a memory and creating recombinations of this. And this is kind of what you see in the traditional folk world today. You see people referencing these old archives, creating kind of recombinations and reinterpretations of these archival canonical songs. So I will just jump over to back to this idea of tactility, materiality of media and memory. So one thing I started experimenting with. After you've recorded to it, you can start using it instrumentally. Let's say tactically playing the memory of the archive itself. Another thing I've been researching is, as I said, voice and different ways of analyzing and segmenting voice. At one point, I was originally thinking, well, can I use speech recognition somehow to create a sort of dialogue with the code that I'm writing as I'm writing it? And this led me to a little bit of research into speech media. I tend to have a very media archaeological approach, I guess you could call it, where when I want to investigate something, let's say speech recognition, I always want to dive into the history of it and see where it sort of bifurcated and where the weird edges were in the history of this technology. So speech synthesis and speech analysis have a very sister-brotherly relationship to each other, so you can't really research one without looking at the other. Essentially because the models of speech synthesis were then used as the same models that were used for speech analysis, at least in the early days. So this is the famous voter by Homer Dudley, one of the first speech synthesizers that used this kind of resonant vocal track model of the voice in order to do synthesis. And I'm just kind of a sucker for these images, so I like to collect them. But when you start digging around in these histories, you find really interesting things. So this is some research that was done and subsidized by the United States Department of State into exploring voice prints to identify criminals. This is essentially, it's a spectrograph, but then on the right, you have this contour voice print, which was an attempt by the researchers to make it look more like a fingerprint, so that the FBI would believe that it was something that could be used to identify criminals. And it's just kind of interesting when you see this kind of thing and think, well, how much the aesthetics of past media determine the success of future media. This wasn't a success, by the way, although voice recognition is used often in forensics, but not like this. So then what can we do with voice analysis? Well, I use a language called SuperCollider. That's what this is, although I tend to do a lot of customizations to the language. What this means is basically writing custom classes, but also writing a macro system that makes it possible to write micro languages inside of it that are a little bit more understandable and readable. So I wrote let's say a wrapper around a speech recognition engine called Sphinx. And Sphinx looks like this. And I can basically run this line and start talking, and hopefully something will happen. Hopefully things will get detected. So are we working now?
So are we working?
We are.
Also only wanting.
Only wanting?
We are careless and we are.
Okay.
Does he have?
So what
To
you saw?
those, yeah.
What you saw
The
there?
witches as our. So are there just are. What are you just are? 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 What are you just are?
Sorry,
What are you just are?
Itself.
Sorry, the misuse is easy to itself. Sorry, that is use is easy. Sorry that it is sorry. I see. Is hard. See. It is. It is. And.
I think it's done.
I think it's the 3 for him. For him. For him. For him. For him, for him, for him, for him, for him.
You almost done?
For an enormous them, for an enormous, for, or an adult. Or it all end. Calling end. Calling end.
Okay, it got a little out of hand there. But as you can see, speech recognition becomes very interesting when you start having some kind of dialogue, whether between me and the machine or maybe between the machine and itself. I was also thinking a lot about code and how code can rewrite itself. So, for example, I don't know, let's say I write something like tick, and let's say I give that meaning, some sort of programmatic meaning, and I give it a behavior. how can storytelling tell part of this? So I'm going to read you a short story. Maybe you know the legend of Zeno of Leah. This is so much work. Hello. So maybe you know the story of Zeno of Leah. So Zeno is famous for creating one of the world's most famous paradoxes, and perhaps the best known of these paradoxes is the story of the tortoise and Achilles. The original goes something like this. The tortoise challenged Achilles to a race, claiming that he would win as long as Achilles gave him a small head start. Achilles laughed at this, for of course, he was a mighty warrior and swift of foot, whereas the tortoise was heavy and slow. The tortoise asks, "How big of a head start do you need, Achilles?" I'm sorry. Achilles asked the tortoise how much of a head start he would want. The tortoise says, "Well, I'll take 10 meters. Achilles laughed louder than ever. "You will surely lose, my friend." In that case, he told the tortoise. "But let us race, if you wish it." "On the contrary," said the tortoise, "I will win, and I can prove it to you by a simple argument." "Go on then," Achilles replied, with less confidence than he felt before. He knew he was the superior athlete, but he also knew the tortoise had the sharper wits. And he had lost many a bewildering argument with him before this. "Suppose," began the tortoise, "that you give me a 10-meter head start. Would you say that you could cover that 10 meters between us very quickly?" "Very quickly," Achilles confirmed. "And in that time, how far should I have gone, do you think?" "Perhaps a meter, no more," said Achilles after a moment. "Very well," replied the tortoise. "So now there is a meter between us, and you would catch up that distance very quickly." "Very quickly indeed. And yet, in that time, I shall have gone a little way farther, so that now you must catch that distance up. Yes?" "Yes," said Achilles slowly. So that you must then catch up a new distance. Achilles said nothing. And so you see, in each moment, you must be catching up the distance between us, and yet I, at the same time, will be adding a new distance, however small. "Indeed, it must be so," said Achilles wearily. "And so you can never catch up," the tortoise concluded sympathetically. "You are right, as always," said Achilles. So what's next? Well, I'm looking into voice classification systems, and I've been doing some research into big machine learning frameworks for doing this kind of work. But in the spirit of getting something working up and quickly and really understanding what's going on, I decided it was more effective to try developing my own system. So 1 second. So here I'm going to capture two phrases, let's say, that I would say. 1, 2, and plot them. So these are, let's say, feature sets for each of the two phrases that I just said. And it's quite a challenge to take such a multidimensional feature set as speech and separate it into a binary, but we can try. So I have my clusters here, but in particular, I'm using 13 features. So that's a 13-dimensional space. And we have to kind of think about, well, are those spaces, or are those features linearly separable somehow? So what we could do is go through the different sets of dimensions and see what they look like by plotting each set together and seeing all the combinations and maybe finding a place where they do look linearly separable. And then the challenge would be to train a model in order to fit that data and then be able to use that in order to kind of train commands and, let's say, dialogues in time. But it would be more interesting, rather than doing the usual machine learning pipeline of training something and then having it optimized and fixed, to create something that's more dynamic and that's constantly destabilized. So that's kind of what I'm researching right now. So this is another data set. This is a randomly generated data set. And what I've done is kind of opened up the training process so that the training process is visualized and sonified in real time. This is a very simple model. It's just a linear classifier, but it could map to much more complex models. Now this is a very clearly dividable data set. And as a result, you get convergence pretty quickly. But what if we create data sets that don't converge so easily? Then we get some dynamics. And we get a temporality, like David was talking about, the way that algorithms unfold create a sort of temporal space. And it can be manipulated in real time. So it becomes a kind of entity to work with and to compose with. And I guess the next step I'm moving towards is to try to combine the vocal analysis with these machine learning processes in order to create a kind of dialogue. Thanks.
Thank you very much, Jonathan Reus. So I really think this became sort of a lecture performance. So thank you very much for that. Are there questions from the audience? Over there?
Hello, everybody. Thank you for your presentation and especially sharing your process at that early stage. I was mostly interested in that short performance piece you presented, interfering the reading with your program. And I was basically wondering in the context of the algorithm if it's like conceptually, I had the idea that the meaning of the words you were saying, they were erased by the sound. Is that like on purpose, or did you already think about? Maybe you can share about some more of your ideas about that relationship between the program, the sound, and the reading voice of yours.
Okay. Well, one of the reasons I choose voice and language is because it has the capability of transmitting meaning of some kind. But let's say like the ontological notion of computation generally abstracts away meaning in place of, let's say, manipulations of symbols. And I really like this tension, actually. And I like to play with this tension more. I think maybe meaning becomes complicated when words and commands start having functional value in the sense that they enact a process in the machine, which is a different kind of meaning. So kind of like a functional meaning versus an interpreted meaning. It's kind of a meaning that executes through time rather than a meaning that's, maybe this old Shannon Weaver model of like the sender and the receiver, where the receiver sort of decodes the information that's inherent in the meaning. I feel like there's these two sort of ideas of meaning that are floating together, and I'm interested in playing with that. I don't understand what you mean by the sound erases the meaning, though. I'm very curious what you meant by that.
It was more a personal impression because I could not follow up the words you were saying because the presence of the sound was just bigger.
I see what you mean.
Yeah.
You mean the sound is in the synthesized voice, or the sound just as in general, the sonic part was more overwhelming than the speech?
The computer was more present than your human voice.
Okay. I think maybe that's just the dynamics problem.
Is there another question? Yes, over there.
Just sort of similarly, whether there was an intended, or maybe the opposite of what you were saying, was there an intended relationship between the paradox and the TikTok?
Yeah, well, the paradox, Zeno's paradoxes on time and motion are all about the idea that if you can discretize time and motion, then you can erase it logically. And so TikTok, incrementing a timer, this is a discretization of time. So there's kind of an interesting tension, for example, what David was talking about these processes creating their own time. I think there's also an aspect to these processes. If you leave them as an abstract concept, like a kind of a concept of discretizing time, then in a sense you erase time. So the TikTok is just a kind of tongue-in-cheek way of referencing the computer's internal timer.
Yeah, I was really interested in the way that the duality between the computer and the way that you converse with it. And it reminded me of like a clinical psychological experiment where you feed the sound, you speak the sound into one side of your head and into the other. Have you thought about sort of getting to a state of like equilibrium with the computer as a dialogue rather than one or the other? So it becomes, the meaning becomes more coalesced together. Have you thought about that?
Equilibrium, yeah, that's an interesting idea, because when the computer is talking to itself, just by the nature of the algorithm, to want to converge to certain words being the highest probability, it tends to reach a kind of equilibrium. These points when it starts repeating the same phrase over and over again because it hears itself, analyzes it, and accurately determines what it's saying, this is a kind of equilibrium, right? But it's an equilibrium where I have no part in it. So then the question is, what would an equilibrium between me and the computer sound like, or look like, or be like? I mean, I don't know if in this sort of scenario there can be a true equilibrium, because I always have the power of agency to perturb the system in a way that the computer arguably doesn't have to perturb my system. Of course, that could be changed. I could give the computer more power, but I think in a live coding environment, I see this process as kind of equivalent to writing. So there is, of course, some pushback from the material, but in the end, I do want to be able to at least put something, inscribe something, have something be inscribed, and maybe that gets transformed, but it doesn't have to be this kind of equilibrium state where it sort of reaches stasis. Because I don't know, equilibrium to me, maybe it's like almost a bad word. It's a curse word in a sense, because like equilibrium is kind of the point where the system converges to a stable point or a steady dynamic. Like an oscillation is maybe a type of equilibrium if you have an oscillator. So I don't know. I mean, I don't know how that would be, unless I'm totally misunderstanding the way you're talking about equilibrium.
I think I'm probably should use the term like an emergence, or an emergence where the human element is equal with the machine rather than this dualistic thing. So you get to a state, a perceptual state, rather than in equilibrium. It could be a parameter of that. I'm sort of like, because it's almost like a conversation, use instruct, react, but there must become a point where the type of instruction could create this emergence in a way. That might be sounding a bit too philosophical, I don't know.
No, but I think I understand what you're saying, where there's kind of a new form that emerges from the combination of the two that's not so distinguishable as either or. That's super interesting.
All right, so the last question will come from Florian Hartlieb.
Thank you very much. I would be interested if there is a deeper relation between your background in the folk music and in the way you sing and write and compose code. So you mentioned that there were some relations, for example, in the percussion style when you play the computer as a drum. But is there a deeper relation between this strongly analog acoustic music and this highly digital code music?
Deeper in the sense of formal relations.
Yes.
Not that I've had the chance to research yet. I mean, of course, with the project in Taiwan, there's a relationship between the weaving patterns, or there's a potential relationship between the weaving patterns and more of an algorithmic sort of process. It's not something I've thought so much about. I've thought much more about the social and material, like the more phenomenological aspects of the folk culture and how the information is kind of absorbed and shared and transmitted rather than the more formal aspects. I feel like that would be a whole new project, but an exciting one. Right. Certainly in banjo playing, there's a lot of very thought out mathematical patterns, because it's essentially like patterns that intermingle in the left and right hand. So it might be something interesting to think about also. Thank you.
All right, so this was the last question. So thank you very much, Jonathan Reus.
Thank you.